Good afternoon, everyone. We are Portage Engineering. My name is Alex Brockett. I'm one of the transportation engineers on this project. We're going to start off with a little bit of general project information, what we've been doing recently, and what the site is looking like. So, our group progress, we were tasked with developing several alternatives and developing a grading criteria to grade those alternatives to ultimately provide an engineer's recommendation for our alternative selection. And then we also wanted to refine our alternatives a little bit between what you saw last time and what you're seeing now in preparation for the technical design memo and report 2. So just a little reminder of site overview here. Up in the northeast corner of the site, there are some FEMA wetlands that we have to try to avoid. There are the power lines running through, and then all those purple lines show the gradient of the site. Those are in 1 foot increments. Moving on to the transportation specific stuff, I've got a general parking lot design. According to the City of Crown Point ordinances, the parking space sizes have to be 10 by 20, so that's what's shown there. This design accounts for 150 total spaces. The City of Crown Point ordinances only required 140 based on our building use. Travel lanes on all 3 sides to try to provide the most access. That little sliver that you see up top in between the large rectangle, which is the building, is a little sidewalk that I'm trying to account for. Total square footage of 68,800 square feet. It's also worth noting that this is the least certain part of the project. Because we don't have a structural engineer, we're not entirely certain what the footprint of the building would look like. So this is potentially subject to change based on what we end up doing for the structural engineer. So for alignment alternatives, I came up with 2. I have 1 alignment running east-west, which you can see on top. And I have 1 alignment that primarily runs north-south on the bottom there. The north-south alignment kind of negates the need for what you're going to see from Josh. The reason I did that is Professor Algebay recommended taking a look into it, as well as we are working under the assumption that Josh is going to transition over to structures next semester, so his stuff won't get fully fleshed out in next semester's design. For our intersection alternatives, I looked at 3 different alternatives for each alignment. We have the minor road stop, an all-way stop, and a traffic signal. The minor road stop is going to be the cheapest alternative. All-way stop has the least total accidents and prevents most severe accidents, whereas traffic signal is most expensive while also being most efficient, and has the least fatal accidents per at it. So for my grading criteria, I decided to look at cost. I did all of these on a 1 to 6 scale, and the way that I weighted it was by having cost. I just did 1 was the most expensive alternative, and then 6 was the least expensive alternative. Whereas for something like safety or context/network, which is weighted a little bit less, that's less objective grading. It's more of a pick a number based on these criteria. So we also looked at level of service immediately after construction, so this is before the rest of the site gets developed. Level of service after the rest of the site gets developed, so I can then use that difference to take a look at the longevity of it. And then also looking at safety based on crashes in Lake County, as well as general statistics for each type of intersection. And in the context/network, I'm primarily looking at how these intersections interact with that Indiana and Summit intersection, as that is very, very busy. So the grades for the alignment running east-west, those 3 alternatives, minor road came out at 22. It had poor level of service after more stuff had been constructed, and it was the most unsafe alternative. All-way stop ended up at a 29, good level of service for both scenarios. It had good longevity and it was cheap. Traffic signal was a 28. It was the most efficient intersection pretty clearly, but it was also very expensive, so that harmed its score a lot. And then for the road running north-south, the minor road stop ended up at a 16. It was unsafe, had poor overall level of service and bad longevity. All-way stop had an 18, poor level of service and bad longevity were the causes for that. and the traffic signal ended up at a 20. It was easily the most efficient of the three that I looked at, but because it was so expensive, it ended up getting harmed. So the highest scoring alternative ended up being the east-west road alignment with an all-way stop intersection that got a 29 out of 36 possible points. Where it lost points was cost and longevity / level of service after further development. So it went from an A right after it was constructed to a C after everything had been developed. And on cost, obviously it lost points because it's not quite as cheap as a minor road stop because there are more stop signs to put in. So why this alternative? You probably noticed the east-west alternatives tended to score higher. That's because the road alignment that I looked at that was north-south was longer, so it was a bit more expensive. And all of those intersection alternatives on the north-south road suffered from backup from northern Indiana and Summit intersection. So it had good level of service right after construction. It was an A right after construction, as I said, and it stayed pretty good at a C. I believe the City of Crown Point ordinances call for a minimum level of service C after construction. It doesn't require much maintenance. You're going to have to get out there about once every 10 years is what NDOT typically does to replace stop signs. And it provides the safest overall intersection. And with that, I am going to pass it off to Josh.
Thank you, Alex. All right, so I'm the project manager for Portage Engineering. I'm also part of transportation. And getting into my alternatives that I came up with, here I've got my first alignment in green tying into the Summit and Thomas intersection. And then my second alignment is in blue. It's just tying in between Thomas and Indiana on Summit Street there. They're both open-ended at the north end due to the fact that I was accounting for it being tied into Alex's Road that runs east-west. And now looking at my grading criteria that I used to decide on an alternative, I looked into the cost of the alternatives. I looked into the level of service coming right after construction and also after the site is fully developed. And then I also looked into safety of the alternatives, looking at crashes and how severe the crashes are. I also looked into how it affects the surrounding intersections and also vice versa. And for my first alignment, I looked into 3 different intersections. First being the two-way stop sign. As you can see at the top left, I put stop signs in the north and southbound approaches. My signalized intersection that I did at the bottom here, I put in a left turn lane for both the eastbound and westbound traffic. And then I also looked at a roundabout. It's a single lane roundabout with right-hand turn lanes. And then here's my details in grading that I did for the first alignment. Roundabouts came out on top. As you can see, it's a little cutoff at the end there. We came out with 14 points as opposed to the 12 and 11 from the signalized intersection, two-way stop. And for my second alignment, I have alternatives being the single stop sign just on the southbound approach, a signalized intersection with the eastbound of the left turn lane added, along with a right turn lane being added to the westbound, and then right hand and left turn lanes being for the southbound. And my roundabout I looked at as well, it's just a regular single lane approaches for that. And the details and grading that I had for that as well. Roundabout in the signalized intersection turned out to be a tie. Overall, the roundabout is more safe and has slightly higher level of service though. And then looking at the pavement costs for both these alignments, the first alignment on the left here in the green came out to be roughly $900,000. And then my second alignment came out to be roughly $750,000 due to the fact that it's just slightly shorter. And my chosen alternative would be the roundabout on the first alignment. That due to the level of service being much higher, able to move traffic through more efficiently, and the safety ratings of that too, being better than the signals and the stop signs, as it causes less crashes and less severity of the crashes. The con being the cost, it's very expensive, but I believe the benefits outweigh the cost in this case. And my parking lot design, finally my parking lot design, I got 29 parking spaces. It's being required of 26 for my building that I'm looking at. I've got 27 regular with 2 ADA parking spots, and I accounted for a two-way lane, and the total cost estimate being $50,000. And moving on to Jacob and Water Resource.
Hello, my name is Jacob Bailey. As mentioned, I'm the Water Resources Engineer for Portage Engineering. Before I get into my slides, I would like to mention there has been a slight change in my scope since our last progress presentation. My last progress presentation, I mentioned the scope outlining treatment of flood control volume for specifically just the roadway and the parcel that we were developing the building on. That has since been changed to developing water quality storage for the whole roughly 50-acre site. So you're going to see some pretty large retention ponds in my alternatives. With that, alternative one, this is the first alternative I developed. It uses permeable asphalt pavement and an infiltration basin on the development site to treat water quality, as well as 2 large dry retention basins for flood control volume. This has a very high filtration capacity. However, there are constructability concerns due to a change in the parking lot design. As I was designing this, initially I was using an estimate that I had for the parking lot square footage that has since been changed to Alex's 68 roughly 1,000 square foot parking lot. And so there are large concerns with the size of the infiltration basin fitting on the site with the parking lot and the building. This standard across all of the alternatives I developed, there are 2 catch basins down on the south side of the development because the watershed follows that there's 2 sub-catchment areas down here that will need to be collected, and then the rest of it kind of flows naturally into one of these 2 retention basins. For alternative 2, I decided to go with the green roof system and rain gardens surrounding the building and the parking lot, as well as these same retention basins. This offered the lowest filtration capacity of the 3 alternatives. However, it still met the overall requirements for water quality volume. Again, catch basins down on the south side, and then denoting a pipe network that will be designed in phase 2 to carry water. Alternative 3, this one incorporates a green roof and permeable pavement for water quality volume, and it incorporates an added wet retention basin for added water quality treatment, as well as the same dry retention basin for flood control. I still consider this, if you see here, this line, that denotes the power lines, and obviously this is crossing it, so it can't work with the way that the alignment is set up. I still included it in my alternative analysis with the thought that the roadway was subject to change with Alex's final design. We know that's not happening, so this alternative is going to have to be thrown out, and that's reflected in my selection matrix. With that, I calculated some removal efficiencies as my scope outlined: removal of total suspended solids by 80% and removal of heavy metals by 60%. The screen little thingy is blocking it there, but for each alternative, they overall met the reduction standards. And this equation was taken from the Lake County Stormwater Technical Manual. And then the removal efficiencies for individual BMPs were taken from relevant literature, as well as the Crown Point Stormwater Technical Manual. After that, I created a cost estimate based off of typical values for construction costs across the Midwest, and typical percentages for operation and maintenance over a 1-year period per Indiana guidelines. And then I also included a 20% contingency for unforeseen costs related to labor, permitting, land acquisitions, and other things. Because of the constructability sizing concerns that I had for the first alternative, as well as the lower filtration capacity of the second alternative, I decided during my alternative analysis to create a second combination alternative that combined the elements from alternative 2, the rain gardens and the green roof, with the permeable pavement system, to have a little bit more ease with where I place those rain gardens, more with the less space being available on the parcel, that offered some wiggle room there. And then with the increase in pervious area of the parking lot, having that permeable pavement offered more infiltration and filtration of that water that falls there. And then also calculated removal efficiencies, and as you can see, they both meet the requirements for my scope. With that, I went into an alternative analysis. I developed a grading rubric, which is not pictured, unfortunately. I weighted the criteria based off of importance to the project and relevance, and then scored each alternative. Alternative 1 and 2 both received the same score. Alternative 3, with that regulatory mismatch there reflected, received a very low score. And then this combination alternative received the highest score, and so that is the alternative that I'll be moving forward with into phase 2. After this, phase 2 includes fully designing geometrics for the piping network, material selection for my different BMPs, as well as designing outlet and inlet structures for my flood control devices, and selection of catch basins to use for those smaller subwatersheds on the bottom of the south end of the parcel. With that, I will hand it on to Ziomara.
Thank you, Jacob. I'm Ziomara Medina. I'm the environmental engineer on this project. Before we start off, I want to do a recap because I did change quite a bit of what I did previously in the previous progress presentation, because I only focused on the structure and the parking lot as opposed to the whole 51 acres. And so I decided to do a lot distribution, and this was just based off of the Crown Point ordinances, making sure that we have space for both infrastructure that's not going to be developed, so those are like the best management practice. That's like the buffer zones around the power lines, around the streets that we're aligning, and then just like commercial lots, secondary commercial lots, and then the mixed use business lot, which is the one that we're going to be designing in the next semester. So for that lot breakdown, it's like 68.7% is available for development, and then the 31.3% is not available. But it's subject to change based on what we decide for our road. So then continuing off of that, the water demand, I also changed it as well. So with what we can develop, I just came up with a couple of connections to the system. So that's like retail, shopping centers, office buildings, restaurants, hotels, medical offices, just like potential uses of what that land can be used for. And then I calculated a water demand with inflow and infiltration into consideration of 40%, just a more conservative value, 481,040 liters per day. And then once I found the average flow rate, the max flow rate, the peak flow rate, I decided to use the peak flow rate, converted that to feet cubes per second, just for the design of the pipe size for the force mains and for the sewers as well. So pipe size alternatives, continuing off of that, I changed it up again. Based off of the 10 state standards though, for the most part it's going to be 8 inches for the mains and 6 inches for the service connections, which are the sewer lines. But I broke it down into PVC, DIP, and HDPE, which are the 3 different pipe materials that I'm going to be considering for the pipe system. And for the most part, they all are within range. There's a bit of like ones that are less or more. So I'm gonna lean more towards cost when it comes to choosing the pipes. And then water demand as well, because some, where the pipes are coming from are gonna be in different soil types. So the collection system, again, I went through the 3 different material types, and I did like a pros and cons list. PVC is gonna always be better just because it's cheaper, and there's more resistance with like chemicals, and the joints don't have much leakage. However, they are not good for heavy traffic. So if we're trying to go underneath the road, that's not gonna be ideal. So I'm gonna probably lean more towards doing a combination of PVC and either DIP or HDPE, depending on the cost. And then for the lift station, I had a CAD file, but it kind of got a little bit corrupted, so I didn't have the layers. And so I just did a quick one from like Google Earth of just locations of where the lift station could be, which is another one of my alternatives that I was looking towards. The one that I lean more towards is point 3, only because it's more so located where there's less traffic. And so it's gonna be more easy for maintenance to come in, check it, and then in case there's like emergency, I need to access it, I could do that. So just making sure when I was doing like the ranking for these, I was just checking based off of the design. So more so how far away they are from the power lines, how far they are from the roads, how far they are from the wetlands, and what they can't be as close to. So focusing more so on ordinances. And then ranking our collection system, again with pipe material, total cost is going to be the #1 driver. I think we've heard all of from the previous presentation too, that like they're going to lean more towards choosing things that are less expensive. So apart from total cost, there's also like velocity range for those pipes, making sure that's between 2 to 10 feet per second, and then just so there's no blockages and there's no like order complaints or any damage to the pipe network. And then also looking into advantages and disadvantages. So that's why I did it based off of my ranking system down there. The higher, the better. So the best option in this case would be PVC. But as I mentioned before, depending on where we are located with where they're going to be like other places that are going to be developed, that's going to change like the pipe material in case we need to accumulate for like a bigger flow. And then ranking for the lift station, similar, just looking more so on elevation, how far they are from roads, from power lines, from wetlands, because NIPSCO has like, they prohibit structures to be 15 feet from the lines, and then same with IDM and tolerances requiring 50-foot non-disturbance buffer zone around that wetlands. So just making sure that the design is able to be approved, and that's the main focus here. And then, as I mentioned before, my CAD file got corrupted. I'm planning on troubleshooting it and fixing it, but because of that, my lengths of how long my pipes are going to be affect how much it's going to cost. So I don't have that shown here, but I'm going to have it in the report that's going to be submitted for report too. And that's the end of our presentation. If anybody has any questions, we're open to them right now. Yes, Mr. Alexander?
Zima, I'll start with you since we are on those slides in here. Now, I don't know if I missed that or not, but your alternatives were based on the materials like PVCs, different other type of piping materials. Do you have alternatives, different alternatives for the layout of the system, of the collection system in here?
As I mentioned, like as you just mentioned right now, I did focus more so on like the location of the lift station and the material of the pipes. The actual layout of how the pipes are going to look like is subject to change.
No, I did not mean how they look like. I mean, where are they compared, because like the transportation people presented like different alternatives where the alignments are, the road alignments are. And so you showed only one alignment for the collection. How about the being in the right of way, for example, for the collection system in the other alignment layouts?
Yeah.
That's what I meant.
As I mentioned before, I did have that in a CAD file, but the layers didn't show up, and I've just been troubleshooting that.
Now, and you just mentioned like the lift stations, and you showed like 3 points. one under the picture or something. But how did you come up with those locations?
I mostly just focused on being more so at like lower points, but being close enough for being like, so that they're accessible, but not too close to like residential or like businesses on the sides of the roads.
So if you go back to that drawing in here, is like point number 3, which is, it seems that the location you have selected in there, is that a lower location compared to point number 1?
Point number 1 is a lower location, but the issue with that one is that because there's so much high traffic on that road, I was focusing more so on accessibility and
You have to explain more for me, why is that impacts? Because it's gonna be on your property and access to that lift station or that point will be away from Indiana, northern Indiana road in there. So why is the traffic a concern?
I think I just prioritize like being able to access the lift station in that case.
I think you made the statement PVC will always be better because it is cheaper. Now, of course, we don't use the word cheaper. It's more cost effective. I think that goes to almost all of you. You use that all along in here, not in there. And then you more or less made a qualifier says, well, for heavy traffic, we use concrete. So why did you make that statement? If it's always better, PVC, if you think like concrete will be more appropriate for different locations?
Primarily, like how you just mentioned right now, for different locations. If I decide to go underneath that road, because it's still subject to change where we're gonna be, where my pipe system is gonna be, I can't have PVC underneath all that heavy traffic.
Okay, so it's not always the best.
It's not always the best option, yes.
Okay, and I'm gonna ding you again on the number of significant figures. So if you go to your cost estimate spreadsheet, okay, in here, why do we have like 20 decimal points over there?
I will minimize those when it comes to.
I think we
report too.
talked about this, we're gonna get that, and besides, these are still estimates, maybe plus or minus 20 or so percent. To the nearest, maybe like 500, 1,000 will be more appropriate, even not to the nearest dollar or like cents, like the previous team presented in there. So when you are still in that sort of cost estimate sort of range, and it's maybe to the nearest, even some cases, like if it's a road, maybe $10,000 will be appropriate.
Well, that'll be harder.
Yeah, okay, I have time, yes? Sure, okay. I'm going backwards from that. Jacob, you got me confused a little bit when you started with your terminology about water quality, volume, and then you sort of mixed that with storage and flood control. So I was not able to separate the terms. And say, so you say like, this is water quality, volume, storage, and flood control volume. So which is which? So can you just explain it to me, like make me understand?
Yeah, so water quality volume, I'm treating 1 inch of runoff and trying to infiltrate or filter that volume of water while also removing those contaminants in the water, so the suspended solids and the heavy metals. And then flood control based off of the 100-year storm that's to reduce flooding, and that's what those larger retention basins were primarily for. I might have had you confused where I mentioned water quality volume with the wet basin. The reason I mentioned that was because the wet retention pond, the sediment can settle, and so while it's not a true water quality volume BMP, it can still add some sort of water quality treatment
Okay,
with that.
thank you for the clarification. Alex, quick question for you. I just want to guide me through step by step how you got the 150 parking spaces in there. And so
How I got the
How did you
150,
get that number, like
the 150
150
that are on the
parking?
plan, or the 140 that are required from the city ordinances?
Well, yeah, you're gonna, if they say required, you wanna tell me why they are required, because
So-
I don't believe so. So that's why I said you
So
wanna.
if you look in the city ordinances, in the tables where it gives you the parking space requirements, the mixed-use building is gonna be 20,000 square feet of office space and 20,000 square feet of apartments or residential. For that, the ordinances say 2.5 spaces per apartment. I estimated that with 20,000 square feet up there, there would be about 16 apartments. Again, that's more of an estimate because we don't have a structural engineer at the moment. So then that's 2.5 by the 16, mental math, that comes out to 40. And then you need, for the offices, it says 1 space per 200 square feet. So for 20,000 square feet, divide that by the 200, that would be the 100. So that's where the 140 required comes from. And then the 150 is just over designing a little bit.
Okay, thank you.
Yep.
Right, so to follow up on that, can you show the parking lot, the design? And to start with, so how do you get the 68,000 square feet? I mean, I guess maybe, what is the size of each parking space?
So each parking space is 10 by 20 on the top there. I didn't include all of those travel lanes, which are in between the parking spaces as well as on the outsides of the actual parking lot. Those are all 24-foot wide.
Okay, because 68,000 is a lot, right? Even
Yes.
for the 10 by
Yes,
20 spaces.
I had this concern as well when I was making it. I reached out to Professor Grossman to ask him if he said that still seemed reasonable.
How big is the lot? This is because this is like almost more than 1.5 acres for the parking lot.
Yeah, the lot is 2 acres, is what we made.
And so like 75% of it is the parking lot.
Yes. I was concerned about it as well, so I reached out to Professor Grossman. He told me that it still sounded reasonable. That was just going off of the City of Crown Point requirements and what Professor Grossman has advised me on.
Well, sorry to interrupt, but I
I was
mean,
gonna say, even
how
if-
much green space are you allowed to have? Because you cannot do that on a 2 acre lot.
That I don't know that off the top of my head.
Okay.
I mean, even if you have 100 square foot per parking space, that's 14,000 square feet. So that's huge, yeah. I mean, yeah, I don't, but so regardless of that, so your building's sitting up on top. So how would, let's say, deliveries be made? So how would the trucks go into your parking lot, be able to turn in the parking lot, be able to deliver things? Like, where are they gonna deliver things to the building? Has
Since
that been considered besides, I mean, I know that you did a good job of explaining the, like, passenger cars kind of basically, right, for daily use. But how about the trucks?
for the trucks, I was planning on being able to use that travel width that's up by the building, to use that as kind of a loading unloading zone. The goal of having access on either side was to hopefully get passenger cars off of that segment of roadway. Obviously, there would still be pedestrians coming across when they enter the building, but
Right, I mean, I would maybe look at it a little bit more as to the trucks pulling up on the side or having, you know, you're not gonna go through the main entrance, or things like that, and be able to turn. So if that parking lot is filled with cars, the trucks won't be able to necessarily get in. It's hard to see if they would be able to use some of that. Yeah, and still check on the side, maybe do a parking garage, then you can have something for, something for structural engineers. But the other question I had was just on the alternatives, let's see. Oh, so for the roadway overall, so where you have the one roadway coming through, and I think that's in both designs. I think most teams have that one roadway coming through. But the question would be is as the site is developed more, are all the other sites that are much further away going to be accessed by a lot of roads that would go off of that, right? So I guess, how do you see off of that main road, providing access to someone whose lot is like is farther down, let's say? How are they gonna get to that
So-
parcel?
A second road would probably be required there. The reason that I elected to tie in so far north is because when I did an analysis of the Summit Street and Indiana Ave intersection, the backup queue that you get from that went almost all the way back to where I'm tying in a peak hour. So I tried to just avoid that to kind of stay out of having issues with that context, especially because turning into that site, the side that the traffic is gonna be backed up on would be blocking where you would try and turn in.
Yeah, I mean, I don't think, my question necessarily just on your design, I think it's on all of them, is to maybe show a parcel layout and just see like how many spokes are you gonna have, how many roadways, which the other team said are gonna be 60 feet wide, right? Cutting back to access all those parcels, and whether it'd be better to maybe shift the road up and have like a second main road. So almost everything is like off of like the main, a main road, right? As opposed to spoking up quite a bit. And it's hard to see because we don't see like where would those parcels be and how far are they and how would they get connected up. But I would maybe recommend that to all the teams to show, although you have one parcel, just to give an idea of like, what would the site look like, how are you envisioning it, and access. So not a ding on you guys, just in general.
There was a signalized intersection. Was that designed for the one parcel being developed or for all the parcels being developed?
So that was what I talked about with the two different grading criteria, level of service right after construction and level of service after further development. Right after construction is with just the one, and then after further development is with everything being developed.
Okay, so then if you included a signalized intersection, the cost with just signal timing, that signalized intersection would work for one or all of those parcels. So that while the cost might be big at the beginning, it could serve all those parcels without any change. Whereas if you make it a four-way stop, when all that stuff gets developed, the four-way stop isn't gonna work, and now you've gotta build a signalized intersection some years down the road, which costs some dollars more.
According to my analysis, the four-way stop, this was using Bistro, the four-way stop was at a level of service C, following everything being built out.
Is there, with everything built out?
Yeah, that's
Okay.
what I got from Bistro. Yeah.
Okay.
So,
Yeah.
so Jacob, you have a wet pond in one of your alternatives?
Yeah.
So how's that gonna remain wet? Is the water table up there, or?
Yeah, and that's outlined in my technical memo, but
Okay.
it's designed for like a always level, certain volume of water in there, and then storage that increases or decreases the actual depth of water in the pond, on top of that like constant amount of water there.
So it doesn't need to have an impermeable liner or anything, just the natural water table will keep it wet?
Well, it would need to have an impermeable liner, I didn't mention
Okay.
that, but yeah, that is something that would need.
Okay.
I figured not to mention it because, again, like, pretty early on, I kind of realized like, this is probably gonna be scrapped anyways because of that, conflict with the power lines, so.
Why do you think that's a reason to remove it? I mean, I know you mentioned that, power, electricity and water, but they are 200 feet apart.
Well, it's part of the the county regulations is, I think the offset, if I remember off the top of my head, 20 feet away from power lines or telephone lines. Like within there, that distance, you can't have any water quality, or flood control storage devices. So it simply just didn't work with the city and county regulations.
So you cannot put a detention pond in the easement of a power line?
I'm sorry?
You cannot locate a detention pond within the easement of the power lines?
Yeah, and it specifies, I think it's 20 feet off the top of my head, but I don't remember exactly. I outlined that in my technical memo as well.
Could you have moved the location, so it could have?
Of
Could you
the
made the
wet
other?
pond?
Yeah, could you made the other one wet pond, and then you would have had a wet pond?
Well, I guess I could have, I didn't think of that. But, I mean, my assumption was, so those both existed on the low points of the watershed. So there was only so much space that I could move that without having to require like a lift pump or something along those lines to get water to those ponds. And then the large retention pond or detention pond in the top or north end of the whole development, because it was so large, and this was also outlined in my memo, I figured, and this is not something that I'm gonna design, but it could double as like a soccer pitch or something when dry, which does kind of make sense from an urban planning perspective, since they have those, Crown Point has those baseball fields just north of the parcel. So that's why I wanted to keep that northernmost pond a dry pond.
Okay. You listed operating and maintenance costs.
Mhm.
I think it was in your analysis, or whatever, like certain percentages, right?
Mhm.
Is that a certain percentage of the construction
Of
cost
the construction cost, yeah.
over the life of the project, or per year, or?
It was percentages over 1 year after, percentage of the construction cost over a year after construction.
So those costs would happen then every year?
Yeah.
Okay. And then I guess the last one for you, Jacob, you mentioned permeable asphalt.
Mhm.
Did you consider pervious concrete or pavers or any other kind of permeable pavement?
I did, I figured I didn't necessarily want to use pavers, because just the nature of the building and its use type, there's going to be a lot of traffic there. And then also, I didn't necessarily want to use concrete either, again, because of that residential aspect, the asphalt is a lot quieter. So, yeah.
Okay. Thanks. And then, Josh, so typically I think of like ADA handicap spaces being bigger, but yours are listed as the same size as the regular spaces. They don't need to be bigger?
I believe as it was on the ordinances that it said it could be a minimum of the 10 by 20, and then the crosshatch was, I think, a minimum as well, like a 5 by 20.
The crosshatch is in between the two handicaps? Okay. So they have the crosshatches?
Yeah.
Oh, okay. I didn't see that on your sketch. Did I just miss it?
It was there,
Okay,
yeah.
it's okay. You don't have to show it.
Okay.
Thanks. And then you had the two different alignments,
Mhm.
right? Like, and I know you compared them and got your preferred, but like, what rationale went into those two alignments? Because they looked like little squiggly lines to me.
Yeah, it was, I mean, I felt it was a little bit better than just, having a straight line, kind of boring. So like, and I thought that like it kind of, when it cuts over, it kind of reaches a little bit into the left turn, or the left corner, left side of the lot. And if there were to be like some other buildings, it could leave like varying sizes at least for development along the road on the east one.
Okay, thanks. And then one question for Alex. I didn't see any handicap spots in yours. Do you have handicap spots?
So I did not account for those yet in parking lot, just because I know it's so subject to change and it's not at all finalized. I decided to leave that out for the time being. It will be in the final design. I have thought of it. I just didn't try to put it into the CAD drawing because of that.
So your 68,000 square foot parking lot would be a little bit bigger?
It would probably stay about the same size because it already has 10 more spaces.
Okay.
So I would just utilize those extra
Okay.
spaces to make handicap spots.
Thanks.
Yep.
You want me to ask? I
Well,
can
you
ask.
said you had
I didn't
one.
ask Josh, so I
Okay.
can ask. Josh, what is the storage capacity for traffic between your roundabout and the next signalized traffic light?
From Thomas to Indiana Avenue.
Yeah, I guess the next street to the east, I think, is Delaware, correct? And so you can go between Delaware and northern Indiana all the way to, I believe, Maribel on the other end in there. So will you have, let's see where this question comes from, where we were looking at the entrance to our campus and the INDOT came back with the city and said there is not enough storage capacity for traffic to put a signal. And so that's why I still remember that. And so in there, is there enough traffic, cars, storage capacity between those like 20 seconds, between like the turning green and red with the light, between the two locations, to those intersections?
For the signals, it definitely wouldn't be, like,
Did you calculate it? Did you figure it out?
I didn't calculate it, but like, when I looked at traffic counts and even if I just looked at like Google Maps, it would just, from Indiana, you could see the traffic build back up, even just up to Thomas from Indiana.
Maybe that's the Black Friday day, so how about the rest of the day of the year? Well, I need some solid answer, Josh. Convince me that's maybe with your calculations, with your numbers, not like the best or the most shopping day of the year.
I don't have the hard numbers unfortunately, but I can look into that.
I'll
later.
leave you alone. I want to ask a question.
Okay, thank you.